Hey everyone, tonight we begin with a journey unlike any other, not across oceans or continents, but across the vast and silent river we all float within, whether we know it or not. Before we drift away together, take a moment to like the video and subscribe, but only if you truly enjoy these quiet explorations. And let me know in the comments where you're tuning in from and what time it is for you right now. I always love seeing who's awake out there under other skies. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease gently into tonight's voyage through the great spiral that holds us all, the Milky Way. Close your eyes for a moment and imagine the night sky, not as a ceiling above you, but as a current flowing through you. The faint, cloudy band we call the Milky Way is no mere decoration. It is the cross-section of a colossal river of stars, a luminous spine stretching 100,000 light-years across. It curves through space like smoke caught in a slow wind, bending and rippling in time you cannot feel. Every spark in that band, every dot, every glimmer, is a sun, some older than all known mountains, others still in the tender glow of birth. Beneath its glow, you are adrift in something ancient. The Milky Way is not a thing to look at. It is the thing you live inside. The air you breathe, the atoms in your hands, the iron in your blood. All of them were brewed in its furnaces long before the Earth existed. To speak of the galaxy is to speak of your ancestry, but measured not in generations, rather in epochs of fire. For billions of years, this galaxy has turned in silence, stitched together from countless smaller galaxies that drifted too close and were gently pulled apart, their stars scattered and rewoven. It is not a single being, but a collection of memories, some bright, some dim, swirling together like pigments in water. Every orbit, every filament of dust, every pulse of light is a note in a song the universe began long before humanity learned to listen. And somewhere in one modest suburb of this grand spiral, a yellow star hums softly to itself. Around it, a tiny blue world turns. From its surface, creatures of carbon and breath look up and see that hazy stripe and call it the Milky Way, unaware that they are seeing only the faintest brushstroke of what surrounds them. From where you sit, you can see perhaps 3,000 stars. That sounds immense until you realize it's a mere droplet of the 100 billion that share this cosmic sea. Think about that every night. Sky you've ever known, every constellation, every whispered wish has been just the tiniest glimmer of the galaxy's body. Most of its light never reaches you, hidden behind curtains of dust or distance. The pale streak we trace with our eyes is the galactic plane, the edge-on view of our own spiral arm. We are looking sideways through a forest so dense that the trunks blur into mist. If you could rise above it, say to a height 1,000,000 times greater than the diameter of the Earth's orbit, you would see the Milky Way as it truly is, a grand whirlpool of stars, its arms sweeping outward in luminous arcs. Between those arms are gulfs of darkness threaded with gas and invisible matter. The whole thing turns once every 225 million years so slowly that even the oldest civilizations on Earth have not seen it move. Yet it is always moving, shifting, inhaling, and exhaling light. Scientists describe it in numbers, diameter, mass, orbital speed, but such figures hardly capture its quiet majesty. Imagine instead a lantern suspended in the void so immense that it could cradle 100 billion suns, yet so delicate that a beam of light takes 100,000 years to cross from rim to rim. That is your home, not your country, not your planet, not even your solar system, but the galaxy itself. And within that home are stories layered like the strata of rock. There are stars older than the Milky Way, remnants of ancient galaxies devoured long ago, still circling the halo like wandering ghosts. There are young clusters in the spiral arm's nurseries of light, wrapped in veils of dust. There are voids so cold and empty that light passes unbroken for millennia. And at the very center lies a shadow, a supermassive black hole 4 million suns compressed into silence, pulling the entire spiral into its patient dance. Yet despite the violence implied by gravity and collision, there is an undeniable gentleness to it all. The stars move as if in slow conversation. Gas clouds drift like thoughts. Even when galaxies collide, their stars rarely strike. They pass through one another like schools of fish, interweaving changing shape but not essence. In this dance, destruction is only another word for transformation. Every star you see tonight is a time machine. The light leaving those distant suns may have begun its journey before the first humans carved symbols into stone. Some began their voyage when dinosaurs still ruled the earth. Some left when Earth itself was molten and young. Each glimmer is a message from a different age, a memory traveling through time to find your eyes. You are not looking at stars, you are looking at history, illuminated. And still, despite our telescopes and equations, the Milky Way keeps her secrets. We don't even know precisely how many arms she has. Some maps say 4, others 2 major ones split and braided by smaller spurs. From our position inside the disk, we cannot see her shape, only fragments of her curves between clouds. Dust hides the truth, and yet the mystery only deepens the beauty. If you've ever stood under a perfectly dark sky, far from cities, far from everything human, you might remember that feeling, the pale ribbon arching above you. Brighter near the horizon, soft as milk spilled across glass. That glow is not outside of you. It's your origin, your address in the universe, your cradle made of hydrogen and gravity. The same processes that sculpt galaxies sculpted you. Tonight, as you lie there listening, the Earth is hurtling around the Sun at 30 kilometers per second, and the Sun itself is sweeping around the galactic center at 230 kilometers per second, fast enough to cross an entire continent in the blink of an eye. Yet you feel still, you breathe, you rest. In that stillness, you are synchronized with motion beyond imagining. The Milky Way is both vast and intimate, a thing of physics and a thing of poetry. To study it is to read an ancient text written in light. To rest beneath it is to feel the hum of creation still echoing through your bones. As we drift deeper into this series, remember this: you are not separate from the stars. You are their continuation, their quiet reflection. Now the night deepens. Outside your window, clouds may pass or crickets sing, but somewhere far beyond all that, the galaxy turns. It has done so for 13 billion years, and it will keep turning long after memory itself fades. And for a brief instant, this instant, you are aware of it, awake inside its dream. Sleep if you can, knowing that your story began in fire, and that the same fire still glows in you. The Milky Way moves, and you move with it, a small warmth adrift in a river of night. Before there were galaxies, there was only darkness and potential, a silent sea of hydrogen and helium left in the wake of the Big Bang. No stars yet, no light, no structure, only a thin breath of atoms drifting through a cooling void. But gravity, that patient sculptor, began to gather this formless mist. Slowly and visibly, it pulled matter into knots. The first stars were born not in peace but in fury. They blazed enormous and short-lived, thousands of times more massive than our sun, living only a few million years before dying in explosions so bright they could have outshone the universe around them. In those deaths, something miraculous happened. They forged the first heavy elements: carbon, oxygen, iron, the alphabet from which all later things would be written. When those stars burst apart, they scattered these ingredients into space, sowing the seeds for everything that would follow: planets, oceans, even you. The Milky Way began in this chaos long before its spiral arms unfurled. Imagine countless tiny galaxies forming across the infant universe, each one a flickering ember of creation. They drifted together, drawn by gravity, merging and merging again, until one great whirlpool took shape, a spiral born from wreckage. This was the ancestral form of our galaxy, young, restless, gathering strength, from the cosmic debris around it. Those first generations of stars are long gone now, but their descendants remain ancient metal-poor suns that still wander the Milky Way's halo like ghosts from a forgotten dawn. Their light is pale and thin, yet when studied, it reveals a chemistry nearly untouched since the universe's youth. To astronomers, these stars are living fossils, whispers of the time before the Milky Way had even formed. Picture one of them, faint red, trembling softly in the dark halo, orbiting high above the galactic plane. It moves slowly, as if tired from the long journey, its path stretched and tilted by billions of years of motion. That light, faint as a candle, began its voyage before our galaxy had a name, before any world circled any star that could call itself home. When you look up, you're looking backward, not just in distance, but in time itself. As matter collected, so did the collisions. Smaller proto-galaxies collided their gas clouds, merging and collapsing under gravity's pull. These cosmic unions were not quiet. They flared in bursts of star formation, setting entire regions ablaze. For every collision, thousands of new suns ignited. And though each spark would one day fade together, they spun the first luminous arms of the young Milky Way, winding slowly outward like ripples on an endless pond. The infant galaxy had no neat symmetry. It was chaotic, warped, filled with violent winds from supernova and with rivers of gas streaming in from intergalactic space. Yet within that turmoil lay the same balance we see today, the quiet agreement between gravity, light, and time. Over eons, the Milky Way began to flatten into a disk, its stars circling a common center. Dust settled, arms curved, and the shape we now recognize began to take form, fragile, luminous, alive. The earliest stars were poor in metals, but as each generation lived and died, they enriched the gas from which the next was born. The galaxy was learning how to make itself more complex, layer by layer. Every explosion painted a new color into its spectrum. Every death fed a future birth. Even then, the Milky Way was recycling, breathing, creating not through chaos, but through rhythm. In some of the ancient myths of Earth creation begins not with order, but with a storm. The gods tear apart, the void mix fire with dust. And from that violent blending, life takes root. The Milky Way followed that same pattern. It is the result of destruction so complete, it became generative. You could say the galaxy is a memory of every explosion that ever was, a record of light refusing to end. We often think of galaxies as eternal things, but even they have a childhood. Ours was a wild one, full of collisions, growth spurts, and change. It didn't appear all at once polished and symmetrical. It had to be built, remade, corrected, and healed. Just as continents drift and species evolve, galaxies do too. Ours found its balance through struggle, through billions of quiet adjustments written in starlight. Imagine standing somehow in that first age. The sky would have looked different, darker, perhaps yet filled with fierce new stars, scattered like sparks from a forge. No Milky Way band yet crossed the heavens because the disk had not yet formed. Instead, separate star clusters hung like islands, connected by invisible tides of gravity. The air, if you could call it that, was filled with radiation from young suns and the faint static of creation itself. Those early stars gave the universe its first color. Their light traveled into the surrounding gas, warming and ionizing it, awakening what had been cold. As the universe brightened, it also grew more transparent. Light could finally move freely, revealing form where there had only been fog. Out of that revelation, galaxies multiplied like coral reefs in an infinite ocean. Our Milky Way found its place among them, one of billions yet destined to become special to us, because we would one day open our eyes within it. The galaxies that merged to form it are long gone, but their stars remain. They orbit high above and below the galactic plane, like ancient ancestors watching over a vast luminous family that no longer remembers their names. The halo around the Milky Way, diffuse nearly invisible, is full of these relics. Some are globular clusters, dense spheres of hundreds of thousands of old stars bound together by gravity's patience. They are the galaxy's memory beads, each cluster older than any world we know, glowing faintly with the light of beginnings. The story of the Milky Way is the story of becoming. Not sudden, not divine, but gradual, a whisper growing into a voice, a spark into a sun. It was not designed yet, it arranged itself into beauty. It was not conscious yet, it produced consciousness. It had no plan yet, here you are listening to it. And that may be the most astonishing part of all, that out of hydrogen clouds and silent gravity, something emerged that could look back upon itself with wonder. That the galaxy, after billions of years of forming and reforming, would one day dream through you about where it came from. As you breathe now, that same ancient process continues. Stars are still being born in the Milky Way's arms, their cradles hidden by dust and distance. Somewhere in those nurseries, new worlds are forming around new suns. They will rise and shine for beings who may one day look up and call it their home too. The galaxy has been alive for over 13 billion years, yet it is not finished. It continues to collect, to merge, to grow its story still unfolding in the dark. And you, for a fleeting heartbeat of cosmic time, are part of that story. Rest easy tonight, knowing this. The light you see in the sky is not only ancient, it is continuous. The same forces that lit the first stars are still burning, still building, still dreaming in silence. The Milky Way is not a memory, it is a motion, and you are moving with it. The Milky Way was never a gentle host. It is vast, yes, and beautiful beyond comprehension, but beneath that beauty lies appetite. Our galaxy, like all great spirals, grew not only by gathering gas and dust, but by consuming others. The night sky, if we could play it in reverse, would reveal the long feast of our home. Countless small galaxies drifting too close, caught in its gravity, pulled apart and absorbed until only ribbons of their light remained. When astronomers peer deep into the halo, they find those ribbons still. They are called stellar streams, delicate trails of stars winding through the dark remnants of galaxies that once wandered too near. The stars now belong to the Milky Way, but their motions still trace the paths of their lost homes, looping across the heavens like the frayed seams of an ancient cloak. The most famous of these ghosts is the Sagittarius dwarf galaxy. Even now, as you listen, it is being torn to shreds, its stars stretched across the Milky Way's outer edge like strands of golden thread. Some of those stars will join our spiral arms, others will drift forever in the halo, fading slowly into the background glow. Sagittarius is dying, but its death is quiet. A long surrender to gravity, a story written in slow motion across 1 billion years. This is how galaxies grow, not in sudden bursts, but in long acts of assimilation. Imagine the Milky Way as a great cosmic weaver drawing smaller galaxies into itself, spinning their remnants into its own pattern. Each merger leaves a scar, yet also adds strength. The galaxy you live in is not a singular being, but a composite, the gathered memories of 100 smaller worlds stitched together over time. One of the most significant of these events happened long ago, when the Milky Way was young and the night sky was crowded with rivals. A galaxy called Gaia Enceladus, smaller but rich in stars, collided with ours. It did not survive, but its remnants did. Astronomers have found them stars with peculiar orbits, moving against the main rotation, older and colder than the rest. They form a kind of inner halo, a fossilized record of that ancient encounter. The merger reshaped the Milky Way, puffing up its early disk and scattering its stars. It might have triggered new waves of star formation, bright flares that illuminated the young galaxy's arms. The echoes of that collision still move through us. Some of the atoms in your body may once have belonged to stars from that devoured world. Even now, the process continues. The Milky Way is surrounded by dozens of dwarf galaxies, faint ghostly companions bound to us by gravity. Most are quiet, but some are being drawn in, stretched, and frayed by tidal forces. The large and small Magellanic Clouds, visible from the southern hemisphere, are two such satellites. Their gas is already being stripped away, trailing behind them in a long stream that curves like a ribbon through the void. One day, they too may be absorbed their light, becoming part of our own. There is something both tragic and comforting in this slow consumption. Galaxies do not die easily. They are recycled into one another. Stars are not lost, they are relocated. The boundaries between one system and another blur until what remains is a tapestry woven from collisions. In the universe, even destruction becomes creation. If you could watch the Milky Way's growth sped up a time-lapse over 13 billion years, you would see it flicker and pulse like a living thing. Small galaxies approach and vanish. Streams of light wrap around the spiral. Arms thicken, warp, and twist. The entire structure grows denser, more luminous. It is like watching coral expand across an ocean floor, feeding on the flow of passing currents. The stars that once belonged to other galaxies now move among ours without distinction. Yet their chemistry still tells the truth. Some are poor in metals, some rich. Their compositions carrying the fingerprints of the worlds that birthed them. Astronomers read those elements as archaeologists read bones clues to forgotten eras of creation. The night sky, in that sense, is an archive of ancient mergers. Each star, a document in light. Perhaps this explains why the Milky Way feels so alive when we look at it, because it is alive in the only way a galaxy can be. It feeds, it transforms, it remembers. Its spiral arms are not pristine patterns of untouched beauty, but scars of growth shaped by every collision that came before. And if the galaxy is a being, then it has a story of inheritance. The stars around you, the same ones you see above fields, mountains, and seas, were not all born here. They are travelers, refugees, adoptees of a greater light. Some wander on tilted orbits looping high above the disk as if unwilling to join the dance. Others move backward, defying the galaxy's spin. These rebels are reminders that even in the heavens, history leaves its dissenters. The process will not stop. Gravity has no mercy, but it also has no malice. It simply continues. The Milky Way is already tugging on smaller companions, the Draco Dwarf, the Carina Dwarf, the Fornax Dwarf, drawing them inward in slow, invisible threads. Millions of years from now, their stars will scatter across our sky, and no one will remember they were ever separate. And farther ahead, a greater destiny awaits. Beyond the halo, beyond the dwarfs, the Andromeda galaxy looms 2 million light-years away and drifting closer every second. In about 4.5 billion years, it will meet the Milky Way in a slow, stately collision. The two spirals will pass through one another, their stars weaving like ghostly hands. It will not be an ending, but a transformation, two rivers merging into one. When that happens, no human eyes may be left to see it, yet the legacy will continue. The stars of both galaxies will join in a new shape, perhaps an elliptical form, smooth and bright. Neither Milky Way nor Andromeda, but something new born of both. The name we give it doesn't matter. What matters is the pattern, the continual renewal, the cosmic acceptance that to survive is to change. Even now, as you rest, the evidence of these past unions drifts above you. Stellar streams like the Orphan and the Helmy Trail, great arcs of light too faint for the naked eye, wrap around the galaxy like the threads of a shimmering cocoon. They are the unhealed stitches of the Milky Way's long making. So when you next look up, remember, you are seeing not just a galaxy, but a family tree of stars, each branch grafted from another world. You live inside a being assembled from others, an inheritance of collisions turned into harmony. In its long hunger, the Milky Way did not destroy what it devoured. It preserved it in motion, in light, in you. Every heartbeat in your chest is powered by the remnants of those ancient feasts, by the ashes of galaxies that became your sky. When you look up into the Milky Way on a clear night, the river of light seems endless, flowing across the sky in a glittering current. But our own place within that river is far humbler than most imagine. We do not dwell in one of the galaxy's grand spiral arms, those radiant highways of star birth that define its luminous shape. We live in a quiet backlane, a small spur of stars tucked between larger structures. Astronomers call it the Orion Spur. To the galaxy, it is a side street. To us, it is everything. Here, the sun drifts through calm interstellar waters surrounded by a few thousand neighboring stars. We orbit the galactic center at a speed of roughly 230 kilometers per second, fast enough to cross an entire continent in the blink of an eye. Yet even at that speed, one full revolution around the Milky Way, a galactic year, takes about 225 million Earth years. Since the sun first lit up, we have completed only about 20 such orbits. 20, that's all. It means that when the first dinosaurs walked the Earth, the solar system was in a completely different region of the galaxy. The stars we see now were not the same companions the ancient Earth once had. The constellations of today are temporary arrangements, threads in a moving tapestry that will change, dissolve, and reform long after we are gone. The night sky looks fixed because our lives are too brief to see it move. Picture the Milky Way as a colossal clock. The core turns swiftly, its inner stars tracing tight circles in just a few million years. But out here in the Orion Spur, we drift along the outer rim, quiet, slow, patient. The galaxy's great arms twist and shimmer ahead of us like distant weather systems we'll never reach. And yet, that distance is our salvation. Near the core, radiation bursts, supernovae, and gravitational chaos are constant. Too close and worlds struggle to survive the storms. Farther out in the lonely galactic suburbs, the material for planets grows thin. But between those extremes lies a temperate band, the galactic habitable zone. Here, the density of stars is moderate, the radiation levels tolerable, and the elements necessary for life abundant. We are adrift within that calm middle region, the galaxy's Goldilocks zone, where time runs long and life has a chance to wonder. The sun's orbit, too, holds a gentle rhythm. It doesn't stay perfectly flat. Instead, it bobs up and down through the galactic plane like a leaf floating on rippling water. Every 30 million years or so, we rise above the disk, then sink below it again. Some scientists once wondered whether that vertical motion might even influence Earth's cycles of life, whether passing through dense regions of the galaxy might affect climate or trigger bursts of evolution. The evidence is uncertain, but the image lingers our world, a tiny ship sailing the waves of a cosmic sea. The Orion Spur itself stretches only a few thousand light years across a narrow bridge connecting two major arms, Sagittarius and Perseus. We live roughly halfway between the galactic core and the outer rim. From this perspective, the Milky Way's central bulge lies 26,000 light-years away in the direction of the constellation Sagittarius. That faint glow you see on summer nights, low and milky on the horizon, is not clouds, it's the crowded heart of our galaxy. Our quiet neighborhood may not be spectacular, but it's hospitable. In the denser regions of the spiral arms, massive stars live fast and die violently, flooding space with radiation that can sterilize nearby worlds. Here, in the relative calm of the Orion Spur, the sun and its planets can drift undisturbed for billions of years. It's the galactic equivalent of a quiet cul-de-sac. No fireworks, no disasters, just peace enough for life to unfold slowly. Think of what that means. If the sun had been born closer to the core, perhaps Earth would have been scorched by a nearby supernova. If it had formed farther out, there might not have been enough heavy elements. No iron for blood, no silicon for rock, no oxygen for breath. Our place in the galaxy is not just random, it's fortuitous. By cosmic luck, we orbit in the perfect balance between chaos and silence. Even the solar system's tilt tells a story. The plane of our planets, the ecliptic, is inclined about 60 degrees to the galactic plane. That's why the Milky Way cuts across the sky at an angle rising from one horizon to the other in a slow, luminous arc. We are sailing through the galaxy sideways like a boat rolling gently with the current. From our small raft, we can see only the faintest fraction of the whole. To the naked eye, perhaps a few thousand stars are visible on the clearest night. Yet the Milky Way contains over 100 billion. It's humbling to realize that every bright point you see is just one of your nearest neighbors, the equivalent of a handful of streetlights in an endless city. And still, even that faint light has power. When you look at the Milky Way's band, you are gazing edge on through the dense heart of our local arm, peering through clouds of dust and newborn stars. Some of that dust once drifted through the same regions the sun passed millions of years ago. Some will one day become the birthplace of new stars that will light the skies of worlds yet unformed. In this sense, our solar system is part of an ongoing story, not a fixed address, but a traveler in a larger motion. At the scale of the galaxy, nothing stays still. Stars migrate, arms drift, orbits wobble. Over billions of years, our sun will complete only a handful of revolutions before the Milky Way itself merges with Andromeda, reshaping everything we know. Yet even amid that slow chaos, there is peace, a kind of eternal rhythm in which nothing is ever lost, only transformed. If you could step outside the galaxy and look back, you might see the Orion Spur as a faint bridge of light curving gently between two brighter lanes. Somewhere within that bridge, invisible to any telescope, is a tiny yellow star. Around it spins a small blue planet wrapped in air and ocean. On that planet, a single species looks up and wonders where it belongs. And in that wondering, the galaxy becomes aware of itself just for a moment. So the next time you find yourself beneath a dark sky, trace that hazy band above you. Somewhere in it, far beyond the reach of sight, lies the sun's orbit. It has carried your ancestors, every tree, every stone, every dream around the galactic center 20 times already, and will carry your descendants countless times more. We are passengers on a long voyage floating in a spiral of light. Our home may be small, but it is steady, warm, and miraculously placed. The Orion Spur is our raft in a river too vast to comprehend, and it drifts on quietly through the sea of stars. If you were to weigh the Milky Way by counting its stars, measuring its dust, and tallying its gas, you'd find something strange. The numbers don't add up. All the visible matter accounts for only a fraction of the galaxy's mass. The rest, the overwhelming majority, is invisible. And yet it's there. It exerts gravity. It holds everything together. Without it, the Milky Way would fly apart like sparks from a wheel. This unseen mass is called dark matter, and it is the quiet architect of our galaxy. It neither shines nor absorbs light. It doesn't clump or swirl like gas. It is simply there, unseen, untouchable, yet essential. Think of it as a ghostly framework woven through space, a web on which all visible galaxies hang like morning dew. We don't yet know what dark matter is, but we know what it does. It is the skeleton of the cosmos. When astronomers map the speed at which stars orbit the galactic center, they notice something remarkable. According to the laws of gravity, we know stars farther from the center should move more slowly, just as the outer planets in our solar system orbit the sun more leisurely than the inner ones. But that's not what happens. Out on the rim of the Milky Way, stars race around almost as fast as those near the center. It's as if an invisible hand is holding the galaxy together, giving weight to what cannot be seen. This discovery reshaped our understanding of the universe. Suddenly, light was no longer the whole story. There was something else, something that neither emitted nor reflected, something that made up 5 times more matter than everything we could see combined. Dark matter revealed itself not by light, but by influence. It bends the paths of stars. It warps space-time. It creates halos that cradle galaxies in gravitational embrace. Our own galaxy floats within such a halo, a vast spherical envelope of invisible mass that stretches hundreds of thousands of light-years beyond the furthest stars. Within it, the Milky Way's luminous disk, the spiral arms, the nebulae, the star clusters, is only a bright core surrounded by shadow. Like a lantern glowing within a translucent shell, the light we see is just the inner spark of something much larger. If you could see the Milky Way in its entirety, not in starlight but in the gravity of dark matter, you'd find it looks less like a tidy spiral and more like a fog of invisible filaments woven together into a luminous center. The visible galaxy is a thin slice of that grander structure, a luminous fruit wrapped in a rind of mystery. Scientists have spent decades trying to uncover what dark matter is. Some imagine it as yet undiscovered particles passing through every atom of your body, this very second trillions of them every moment without leaving a trace. Others think it might be a property of gravity itself, a flaw in the equations we use to describe the cosmos. We don't know yet, but whatever it is, it makes galaxies possible. Without dark matter, the Milky Way's outer stars would drift away into intergalactic space. The spiral arms would unravel, flinging stars like sparks into the void. The galaxy's form, its luminous symmetry, depends on the gravity of this unseen mass. It is the quiet glue of the universe, and we owe our very existence to it. Dark matter not only holds galaxies together, it also shapes how they form. In the early universe, long before stars existed, it clumped under its own gravity into massive halos, invisible seeds that drew gas and dust toward them. Within those halos, the first galaxies were born. The Milky Way grew inside one of these invisible cocoons. In a sense, dark matter built our home first, then invited light to move in. Imagine it a structure made of pure gravity, a framework on which all of history was hung. Galaxies are not random. They form where dark matter gathers. The great filaments of the cosmic web, the vast networks connecting galaxies across billions of light years, are made not of stars, but of this unseen substance. The Milky Way is one bright bead strung along that endless thread. Even now, dark matter continues to influence everything around you. The gentle tug that keeps the Earth bound to the sun bound to the galaxy bound to the local group. All of it happens within the gravitational fields sculpted by dark matter. You are moving through it at every moment. You breathe within it, though it has no scent or sound. It's easy to think of the cosmos as a battle between light and darkness, the luminous and the void. But perhaps it's not a battle at all. Perhaps it's a partnership. Without darkness, light would scatter and fade. Without light, darkness would remain unseen. The Milky Way, like every galaxy, is a union of both radiance held within a silent frame. If you could feel dark matter the way we feel sunlight, you would sense it everywhere. It stretches above you, beneath you, through you, an invisible ocean in which the galaxy floats. You are suspended in it right now, resting on a planet that is itself drifting through this unseen sea at hundreds of kilometers per second. And though it is silent, it keeps you tethered not just to the Earth, but to the heart of the Milky Way itself. Every night when you gaze upward, you are looking into a paradox, a galaxy that should not exist, yet does. A wheel of stars spinning too fast to hold together, yet somehow intact. What holds it is the invisible, a substance without color or touch, known only by its pull. There is something profoundly poetic in that idea, that what sustains us, what gives structure to everything we know, is something we cannot see. The universe, it seems, is built on faith, not blind faith, but gravitational faith. Stars trust the unseen, and in doing so, they remain bound. And so do we. As you lie there, think of that invisible web stretching beyond sight. Every atom of your body, every photon that touches your skin, moves through that same cosmic lattice. You are not merely surrounded by the galaxy, you are part of its framework. You exist within its invisible architecture, a living fragment of the structure that holds everything together. The Milky Way's beauty is not just in what shines, but in what doesn't. Light tells only half the story. The rest is written in the dark. At the very center of the Milky Way lies something both terrifying and tender, a heart made not of light, but of gravity. It is called Sagittarius A, a supermassive black hole weighing more than 4 million suns. It occupies a space smaller than the orbit of Mercury, yet its influence extends across the galaxy. Everything you have ever known, every planet, every star, every orbit, moves in quiet obedience to its pull. We cannot see Sagittarius A directly. It hides behind thick clouds of dust and gas that veil the galactic core from ordinary sight. Yet we can feel its presence in the motion of stars. Astronomers have watched these stars bright, young, and fast, whipping around an invisible point with breathtaking speed. Some complete their orbits in just a few years, racing through space at thousands of kilometers per second. Only a black hole could hold them so tightly. If you could stand near that region, impossible, of course, but imagine it, the sky would burn with light. Millions of stars crowd the core, each one brighter than our sun, their combined radiance filling the darkness with a golden haze. Clouds of dust swirl between them, glowing in infrared, twisted into rivers by the pull of gravity. In the midst of it all lies the black hole, silent, patient, pulling everything inward. Sometimes gas drifts too close. It spirals down into an accretion disk, a whirling ring of fire millions of kilometers wide. As it falls, the gas heats to incredible temperatures, glowing in X-rays before vanishing beyond the event horizon, the point from which no light escapes. For a moment, the darkness flares. The galaxy's heart beats once in light, then falls quiet again. Long ago, this heart may have burned much brighter. Astronomers have found traces of vast bubbles of gamma radiation rising above and below the galactic plane. The Fermi bubbles, glowing arcs tens of thousands of light years tall. These may be the fossil echoes of a time when Sagittarius A was awake, feeding greedily, blazing like a quasar, and illuminating the entire Milky Way from within. Now it sleeps, murmuring only faintly in radio waves, and X-rays a giant resting between dreams. Even in its slumber, its presence shapes the galaxy's structure. Around it stretches the central bulge, a swollen sphere of stars gathered by gravity over billions of years. But this bulge isn't smooth. It's strangely shaped, a peanut or an hourglass puffed out by the slow rotation of a dense stellar bar that cuts through the core. Picture it a bridge of stars, thousands of light years long, rotating gently, stirring the gas that feeds new star formation and occasionally, perhaps, the black hole itself. From Earth, when you look toward the constellation Sagittarius, you are looking directly toward this heart. The thick lanes of dust you see in long exposure photographs are the Milky Way's arteries, rivers of keys flowing into the core. Those dark bands across the sky, which once looked like cracks in heaven to ancient peoples, are not empty. They are full of light, hidden behind veils of carbon and silicate dust glowing in wavelengths the human eye cannot see. In the myths of many cultures, the center of the world is sacred, a place where life and death meet, where everything begins and ends. The Milky Way's center is that kind of place. Their creation and destruction are the same act. Matter falls and vanishes, and in doing so releases energy that lights the galaxy. What we call nothingness becomes a forge of stars. To grasp a black hole is to grasp the limits of understanding. It is not merely a hole, it is a region where space folds back on itself, where time curves so steeply that all directions lead inward. Inside, physics, as we know it, dissolves. No signal escapes, no memory returns. It is as the poet John Michel first described centuries ago, a dark star. And yet, paradoxically, its existence gives structure to everything around it. Even here, far away on Earth, we orbit in response to that distant gravity. The sun's slow path around the galaxy is, in the end, a curve around Sagittarius A. You have spent your entire life in its field, every breath taken in the pull of something you cannot see. It is the center not only of the Milky Way's mass, but of its motion, the point around which all stars turn like lanterns around a quiet well. And yet the black hole is not alone. Around it orbits a cluster of stars known as the S-stars, each moving in a dizzying ballet. One of them, called S2, has been observed for decades. Every 16 years it swings close to the black hole, accelerating to a few percent of the speed of light. During its closest pastime, itself slows for it, an effect predicted by Einstein's relativity. To watch S2 move is to see physics in motion, to witness gravity bending the fabric of reality. When scientists finally captured the first image of Sagittarius A using a global network of radio telescopes called the Event Horizon Telescope, they didn't see a hole at all but a ring, a faint fiery halo surrounding a perfect dark center. That image is not just a picture, it's a mirror. It shows us what we cannot otherwise imagine the universe contemplating its own depth. If galaxies were living beings, black holes would be their hearts, places of silence, rhythm, and return. The Milky Way's heart has pulsed for billions of years. Sometimes it glows, sometimes it rests, but it always draws, always holds, always binds the spiral together. Perhaps that's what makes this so moving, that something born of collapse of infinite inwardness can hold such harmony. Sagittarius A is gravity incarnate, but it is also balance. It teaches that even the darkest thing can be the center of order, that what disappears can still give shape to what remains. Tonight, as you lie beneath the faint shimmer of the galactic band, remember that all of it, every bright star and every shadowed space between, turns around one silent point of gravity. In its stillness, it keeps the galaxy whole. It may be black, but it is not empty. It is the Milky Way's heartbeat, slow, unseen, eternal. From a distance, the Milky Way might look like a frozen pinwheel, bright spirals of starlight winding gracefully through the dark. But that image, while beautiful, is an illusion. The spiral arms are not solid things. They are not celestial bridges where stars stand still. They are waves, patterns of density moving through the galaxy like ripples through water or sound through air. The Milky Way doesn't hold its shape, it plays it. Every arm you see is a moment in that ongoing rhythm, a temporary arrangement of matter shaped by gravity and motion. The arms are more like songs than sculptures, and each turn of the galaxy is another verse in a melody 13 billion years long. Imagine a crowd of travelers walking in the same direction down a wide street. Some walk faster, some slower. At moments, groups bunch together, forming temporary clusters before spreading out again. The spiral arms form in the same way as regions where stars, gas, and dust gather briefly in greater density before drifting apart. They are not fixed, they are process. When the waves pass through the galaxy's disk, they compress the clouds of hydrogen that drift there. Under that pressure, gravity takes over and new stars are born. The arms are therefore the nurseries of light places of constant creation. Young massive stars ignite along their length, shining blue and bright against the softer glow of older stars. These newborns live fast and die violently, scattering the elements of life back into space, sowing the next generation of stars that will light the arms once more. The light you see when you gaze upon the Milky Way is therefore not evenly spread. It's laced with glowing filaments where the waves of density have recently passed, leaving behind fresh constellations of fire. Between those filaments lie darker lanes, quieter regions where star formation rests, waiting for the next pulse to arrive. In this sense, the Milky Way breathes. The spiral arms are the inhalations and exhalations of a living structure. They sweep outward slow and majestic like the hands of a clock made of light. The stars within them are born live and die, all within a single passage of that clock's hand. None last long enough to see the arm complete its turn. And yet, because the pattern endures, the galaxy always appears to be the same shape, timeless, eternal, though every particle within it changes. You might picture the arms as great cosmic highways, but that's not quite right. They are traffic jams, slow-moving zones where matter bunches together. The cars in this analogy are the stars themselves, each traveling at its own pace, yet temporarily caught in the rhythm of the jam. The pattern of congestion moves on though the cars do not, and just like that, the galaxy's arms move at a different speed from the stars that define them. This dance of motion is delicate and strange. Our sun, for instance, is not fixed within one particular arm. It moves in and out of them as it orbits the galactic center, spending tens of millions of years in bright, busy regions before drifting into quieter lanes. Each transition marks a new era of our solar neighborhood, new stars rising around us, old ones fading behind. For life on Earth, this slow passage may matter more than we realize. The spiral arms are rich in supernovae and intense radiation. The spaces between them are calmer, safer. Some scientists believe our current location in the Orion Spur, a small quiet branch between major arms, is one reason life has flourished here. The galaxy's music is not just beautiful, it's merciful, giving long silences between its crescendos. The spiral pattern itself is sustained by a kind of galactic resonance, a balance between gravity, rotation, and inertia. In the inner regions where stars orbit faster, the spiral waves tighten. Farther out where motion slows, they stretch and fade. The result is not perfect geometry, but a shifting, breathing swirl of light and shadow. If you could watch the Milky Way in accelerated time, it would seem alive, arms flexing, twisting, winding their tips, curling like fingers around the dark. And yet for all its motion, the pattern holds. This persistence is part of its magic. Every arm is a memory of motion preserved in form, a visible record of how the galaxy has moved through time. Each wave began as a tiny irregularity, a small difference in density, amplified by gravity's endless feedback. Over billions of years, those irregularities became music, and the music became structure. Even dust, that soft haze that obscures and reveals in equal measure, plays its part. Within the spiral arms, dust outlines the lanes of compression. It absorbs starlight and glows in infrared, tracing invisible harmonies across the disk. In the same way that the sound of a cello depends on the vibration of its wood, the song of the Milky Way depends on the vibration of dust and gas within its arms. To the ancient peoples who looked up at the night sky, the Milky Way was a road of spirits, a river of souls, a bridge between realms. And they were not wrong to see it that way. For the galaxy truly is a bridge, a conduit between chaos and order, between creation and decay. The spiral arms carry the memory of what was and the promise of what will be, binding them into an unending circle. If you could listen instead of look, perhaps you'd hear it not with ears, but with imagination. The deep, slow pulse of gravitational rhythm, the hiss of gas collapsing into stars, the brief, sharp notes of supernovae like drums in the distance, and above it all, a constant undertone, the hum of the galaxy, turning the sound of time folding itself into light. Our Milky Way is not a sculpture carved by the gods. It is a song written by motion, the same motion that carries you around the sun, the same rhythm that beats in your chest. Every rotation of the galaxy is a stanza, every arm a phrase, every star a syllable of the great hymn of existence. And the melody, it never ends. It only changes. It echoes in the atoms of your body, in the light that warms your skin, in the quiet breath you take as you listen now. You are, after all, part of that music, a note in the vast, unfolding harmony of the Milky Way. Between the Milky Way's spiraling arms lies darkness, not empty space, but the soft obscurity of dust and gas. It is in these shadows, not in the glare of starlight, that creation begins. The galaxy's brightest children are born in its darkest rooms. These regions are called molecular clouds, vast cold accumulations of hydrogen and carbon spanning hundreds of light years. Inside, the temperature can drop to just a few degrees above absolute zero. There is no glow, no sound, only the slow swirl of matter gathering under gravity's pull. From a distance, these clouds look like stains across the Milky Way's glowing band. To the naked eye, they appear as absence. But inside, invisible to ordinary sight, suns are forming. Picture 1. A silent cloud drifting between the stars. Within it, density builds. Small knots of gas begin to collapse, drawing more material inward. As they do, they spin faster, flattening into disks, the embryos of solar systems. At the center of each disk, pressure grows until hydrogen atoms fuse, releasing light for the first time. A star is born not with noise, but with warmth. Its light seeps through the surrounding dust, painting the darkness with faint red and gold glows. This process repeats endlessly across the galaxy. Where the spiral arms pass through these cold clouds, gravity compresses them, triggering new rounds of star formation. The result is a constellation of stellar nurseries, glowing regions like the Orion Nebula, the Eagle Nebula, and the Carina Nebula. They are the galaxy's cradles of fire, chaotic luminous, filled with turbulence and beauty. In visible light, they shimmer with pinks and violets, colors of hydrogen excited by young suns. In infrared, they reveal the silhouettes of still-forming stars hidden inside cocoons of dust. Each glowing pillar, each curling ribbon of gas, is a testament to gravity's patience, the slow art of sculpting light from darkness. You can imagine these places as the wombs of time. Every grain of dust, every atom of gas participates in a cycle that has gone on for billions of years. Stars are born, they live, they die, and their remnants drift back into space, enriching the next generation of clouds. The calcium in your bones, the oxygen in your lungs, the iron in your blood. All of it once hid inside a cloud like this before finding its way into a star that exploded long ago. To look at a molecular cloud is to look at potential, the galaxy's dreaming state. The darkness is not emptiness, but concentration, a deep inhalation before the next act of creation. These regions are delicate, too cold and they stay still, too hot and they scatter. Only in balance can they give birth, and that balance is fragile. Massive young stars newly formed can destroy the very clouds that created them. Their fierce radiation pushes gas outward, carving vast cavities that glow at the edges. When enough stars are born together, their collective winds and explosions blow super bubbles through the galaxy, punching holes in the interstellar medium. The Milky Way breathes through these wounds, exhaling gas into the halo, then drawing it back down again in slow gravitational tides. Seen from afar, this process gives the spiral arms their mottled texture, glowing knots of creation interlaced with dark lanes of dust. The arms are not smooth ribbons, but patchwork quilts, a constant interplay of birth and erasure. The brightness you see in the Milky Way's band is the signature of this struggle light, pushing against shadow creation, against collapse. Yet even the dust, the so-called veil of darkness, is essential. Without it, the gas would never cool enough to condense into stars. Dust grains act like cosmic thermostats, radiating away heat and allowing gravity to take hold. They are also the carriers of complex chemistry. On their tiny surfaces form molecules like water, carbon monoxide, and ammonia, the same substances that later become oceans, atmospheres, and the chemistry of life. When you see a dark nebula, that soft, irregular patch blotting out the stars, know that it is not a void. It is a nursery in waiting. The darkness you see tonight may shine tomorrow, or in 1,000,000 years, or in 100 million. Time moves differently there. Stars do not hurry, and so the Milky Way builds itself from patience. The spiral arms sweep by compressing gas. Stars ignite, dust thickens, the cycle continues. The galaxy is both mother and child, endlessly renewing itself from its own remnants. If you could hover near one of these stellar nurseries, say within the Orion Nebula, you would see a sight beyond comprehension. Great walls of gas glowing softly, jets of material shooting from infant stars. Magnetic fields coiling in silent elegance. Everywhere motion, everywhere transformation. And somewhere in that chaos, a small disk of dust beginning to form. Planets, worlds, not yet solid oceans, not yet liquid skies, not yet blue. The Milky Way, for all its size, is intimate in this way. The same processes that built those distant suns built ours. The sun was born from a cloud like this 5 billion years ago in a cluster of siblings now scattered across the galaxy. Some of those long-lost sisters of our sun still wander among the stars, carrying with them memories of our shared birth cloud. That cloud is gone, now dissolved into space, but the dust remains recycled, remade, reincorporated into new stars. Every glittering point of light you see tonight is part of this endless lineage. The galaxy is a family tree whose branches grow from ashes. So the next time you gaze at the Milky Way's misty band, remember, you are seeing not the sky's emptiness, but its fertility. The faint glow, the dark streaks, the blurred patches, they are the living evidence of creation in progress. The galaxy is not finished. It is always giving birth. And in that act of eternal renewal, you too are included, a being of dust and starlight carried gently in a spiral arm of an ever-creating universe. Sleep well tonight beneath those silent cradles of light. Somewhere in the dark, new stars are being born, their light already traveling, destined to join the great river of the Milky Way, and perhaps someday to shine upon new eyes that will wonder as you do now. The Milky Way may look whole and steady from afar, a single spiral, luminous and serene, but beneath that beauty lies the memory of violence. The galaxy we call home was not born in peace. It was assembled from collisions, mergers, and quiet devourings stretched across billions of years. Our galaxy is a collector of ghosts. Every smaller galaxy that strayed too near was pulled in, shredded by tidal forces, and absorbed into the greater whole. Their remnants are still here, scattered through the halo in faint stellar streams, long ribbons of stars tracing elegant arcs across the sky. These streams are the fingerprints of history, each one a record of a devoured world. Imagine them, faint lines of starlight wrapping around the galaxy like strands of silk. Some are tens of thousands of light years long, so thin they can only be seen with sensitive instruments. Yet they tell a story of cosmic hunger and inheritance. The Sagittarius dwarf galaxy, for instance, is being torn apart right now. Its stars stretch into a luminous loop that wraps around us, forming a river of light that flows through our skies even as the parent galaxy dies. Every star in those streams was once part of a smaller realm, a galaxy with its own clusters, clouds, and perhaps even planets. Now they drift within ours, folded into our structure, but still moving to their old rhythms. Their chemical compositions are subtly different, carrying the accents of another home. To astronomers, these variations are as telling as fossils, proof of ancient mergers hidden beneath the Milky Way's glow. When you look up at the night sky, you are looking at a palimpsest, a text written over many times, its earlier stories still faintly visible beneath the new. The Milky Way is not a single creation, but a collage. The stars around you do not all share the same ancestry. Some were born here. Others came from long-vanished galaxies whose names we will never know. The Gaia-Enceladus merger, one of the largest in our history, happened about 10 billion years ago. A smaller galaxy collided with our growing spiral, pouring in billions of stars. That collision reshaped everything, thickening the Milky Way's disk, creating new generations of stars, and leaving behind a population that still orbits differently from the rest. You can trace them today in the thick disk, older, slower stars, moving on tilted paths carrying the scars of that long-ago impact. Over time, dozens of such galaxies have fallen in, some no larger than star clusters, others massive enough to alter the Milky Way's core. The halo surrounding our galaxy, that vast, nearly invisible sphere of ancient stars, is made largely of their remains. In those outer reaches, stars drift in long, looping orbits that take billions of years to complete. They are the oldest citizens of our cosmic city, elders who remember a time before the Milky Way had spirals or arms at all. And yet, for all its violence, this process is not destruction alone. It is transformation. When galaxies merge, their stars rarely collide directly. Space is simply too vast. Instead, they blend gravitationally like two clouds merging in slow motion. The smaller galaxies' stars are drawn out in long tails. Its gas compresses and ignites new star formation. In this way, the Milky Way grows richer, more complex, more alive. Every collision is a creative act disguised as ruin. Even now, new mergers are underway. The Sagittarius dwarf is one. The large and small Magellanic Clouds, visible from the southern hemisphere as glowing smudges in the night, are another. Two bright satellite galaxies orbiting and slowly feeding material into our own. They trail behind them a vast Magellanic Stream, a ribbon of hydrogen stretching across the southern sky. Someday, they too will be absorbed, their stars woven into our spiral fabric. The Milky Way, in this way, is not a static form. It's a living record of relationships of attraction and assimilation, of dance and dissolution. It has eaten perhaps 50 smaller galaxies over its lifetime, and each one left a trace, a whisper, a curve of light where its stars now drift. Astronomers track these whispers using chemical tagging, reading the elemental fingerprints of stars to trace their lineage. Some are rich in heavy elements, the products of many generations of star birth and death. Others are almost pure hydrogen and helium relics from the early universe. By mapping these fingerprints, scientists can reconstruct the family tree of the Milky Way, a genealogy written not in blood, but in starlight. In ancient myth, the Milky Way was often seen as a river, the river of heaven, the silver path the cowherds crossing in Chinese legend, where lovers separated by the sky could meet once a year. How fitting that this mythic river is real. A flow of stars shaped by gravity and time, carrying within it the remnants of countless worlds. Every stream in the halo is like a tributary joining that river. Some wrap around us like invisible rings. Others plunge toward the galactic center, their stars spiraling down in slow arcs that will take eons to settle. The Milky Way's outer halo is therefore not empty, but full of motion, delicate, continuous, and unseen. It is our galaxy's outer memory, fading but not forgotten. And though we think of galaxies as solitary islands in space, the truth is that they are archipelagos, bound groups drifting through a larger sea. The Milky Way belongs to the local group, a cluster of more than 50 galaxies bound by mutual gravity. The nearest Andromeda approaches us even now, moving silently through the void. In 4 billion years, the two will merge their stars, mingling in a cosmic waltz. The rivers of the Milky Way will become rivers of a new galaxy entirely, a future creation born from the union of two great spirals. When that happens, our streams of memory, these delicate ribbons of stars from past galaxies, will stretch once more, bending into new patterns, new harmonies. The cycle will continue, creation through encounter, beauty born from gravity's embrace. It is strange, perhaps, to think of such vast collisions as gentle, but in cosmic time, they are. Stars glide past one another in silence like dancers crossing in slow motion. Galaxies merge not with explosions, but with grace. Out of their union, a new shape emerges, a deeper harmony written across the dark. The Milky Way, for all its peace tonight, is still becoming. Its edges are still catching faint rivers of stars from afar, still whispering to its smaller companions with the pull of gravity. And somewhere in that endless folding and refolding of light, We continue to orbit one tiny world within a galaxy made of memory. When you look up at the night sky, remember those faint threads. Those shimmering bands are not just stars. They are stories, the histories of ancient galaxies drawn thin across the heavens, still moving, still remembering, still home. To understand the Milky Way, you must accept a quiet, unsettling truth. Most of it cannot be seen. The luminous spiral, the bright core, the rivers of stars and dust that we call our galaxy. These are only a fraction of what truly exists. The rest, the overwhelming majority, is invisible, and yet it holds everything together. This unseen substance is called dark matter, and it outweighs all the stars' gas and dust combined by a factor of several to one. We do not know what it is. We cannot touch it, trap it, or make it shine. But we feel its gravity everywhere, shaping the galaxy from the inside out like a sculptor whose hands never appear. The mystery of dark matter began with motion. When astronomers measured how stars orbit the center of the Milky Way, they found something strange. The outer stars, those far from the core, were moving far too fast. According to Newton's laws, the farther a star is from the center, the slower it should orbit, just as the outer planets move more leisurely around the sun. But in our galaxy, the stars in the outskirts spin almost as swiftly as those near the heart. By every normal rule of physics, those stars should have flown away into the void. Yet they remain held as if by an invisible hand. That hand, scientists realized, must be made of matter. We cannot see an immense unseen halo of mass surrounding the entire galaxy, extending far beyond the visible spiral arms. If you could see dark matter, the Milky Way would look utterly different. The glowing disk of stars would be just a bright core inside a vast, faint sphere. This halo stretches hundreds of thousands of light years in every direction, wrapping our galaxy in a cocoon of gravity. The halo is not solid. It is diffuse like fog, but massive beyond comprehension. Dark matter doesn't emit light nor absorb it. It passes through normal matter as if through air, yet its gravity is undeniable. It shapes how galaxies form, how they cluster, and how they survive. Without it, the Milky Way would simply fly apart, a loose scatter of stars drifting into the dark. We are, in a very real sense, inhabitants of the unseen. Every orbit, every star, every planet owes its stability to this hidden mass. It is the scaffolding of the cosmos, the silent architecture upon which everything luminous depends. And yet, though it defines the galaxy, we do not know what dark matter truly is. Some theories propose exotic particles, WIMPs, axions, or other yet undiscovered entities born in the first moments after the Big Bang. Others imagine more radical possibilities, alternate forms of gravity, new dimensions of space, or relic fields from before time began. None have yet been proven. We build detectors deep underground and beneath mountains shielded from radiation and noise, hoping to catch even a whisper of dark matter's presence, a single, rare collision with ordinary atoms. For decades, the instruments have waited in silence. But sometimes that silence itself is an answer that the universe still keeps secrets, even from its keenest minds. In the Milky Way, the effects of dark matter ripple through every level of structure. It shapes the paths of stars, the speed of the sun's orbit, even the distribution of dwarf galaxies that circle us. The Magellanic Clouds, for instance, follow paths influenced not only by our visible gravity, but by the invisible halo's reach. Their long, gaseous tail, the Magellanic Stream, curves and twists under the pull of that unseen force. Even the galaxy's faint warp, that subtle bending of its disk like a slow wave, may be caused by clumps of dark matter tugging at its edges, the unseen reshaping the seen. If you could float high above the galaxy and watch it spin, you'd see the luminous matter move like light across a hidden skeleton, the bright spiral wrapped around an invisible frame. That frame does not glow, but it gives the galaxy its coherence, its integrity, its grace. And though we call it dark, perhaps that name misleads us. It is not darkness in the sense of shadow or evil. It is simply unseen, a silence that makes the music possible. Just as air carries sound without being visible, dark matter carries gravity's melody through the universe. Without it, the stars would not hold together, the spiral arms would not form, and life itself, which depends on stable galaxies, stable stars, stable time, might never have had a chance to emerge. The unseen gives rise to the seen. There is humility in that idea, that what matters most may not be what shines, that the fabric of our existence is woven not from light, but from what light cannot touch. Dark matter also connects us to the wider universe. Every galaxy we can see is surrounded by such a halo. Together they form the cosmic web, vast filaments of dark matter stretching between clusters like the framework of a colossal organism. Along those filaments, gas flows inward, forming galaxies at their intersections like dew forming along strands of silk. The Milky Way is just one glowing bead on that dark, endless web. Astronomers call this web the large-scale structure of the cosmos, and it is made mostly of dark matter. The visible universe, stars, planets, nebulae, everything we have ever seen is just the luminous frosting on that invisible cake. It's strange to realize we are surrounded, permeated, and supported by something we can neither see nor feel. And yet, we owe it everything. When you look up at the stars tonight, you are not merely looking at light. You are looking through the window of the unseen, through a gravitational sea that holds the galaxy in place. Every twinkling star is a buoy floating on that invisible ocean. Perhaps in the end, dark matter is not a mystery to be solved, but a reminder to be humble, that the universe is larger than our senses, that the most powerful forces in existence may be the ones that do not reveal themselves to our eyes. You are right now part of that hidden structure, drifting through a dark halo so immense, it defies imagination, held in its quiet embrace as you orbit the galactic heart. The Milky Way glows because of what it cannot see, and so do we. If the Milky Way is a living being, then its breath is the rhythm of creation and destruction, the long, slow inhalation of birth, and the equally patient exhalation of death. For though the stars seem eternal, they live and die just as surely as we do. And in dying, they give the galaxy life again. Every star you see in the night sky is part of a great cycle. It was born from the ashes of older stars, burns its fuel in quiet or violent radiance, and will one day return its matter to the galactic sea. Nothing in the Milky Way is truly new. It is all recycled starlight remade endlessly through time. The story begins with gravity, that patient sculptor. Within molecular clouds, gravity pulls atoms together until a new star ignites. Around it, leftover dust and gas gather into planets, moons, and comets. For millions or billions of years, that system shines steady, rhythmic, serene. But the peace never lasts forever. When a star exhausts the hydrogen in its core, it begins to change. Small stars like our sun swell into red giants, their outer layers drifting outward like petals in the wind. Eventually, they shed those layers entirely, forming delicate planetary nebulae shells of glowing gas expanding into space. What remains at the center is a white dwarf, a cinder of carbon and oxygen, small as Earth, yet heavy as a star. Massive stars, however, meet a far more dramatic fate. When their fuel runs out, gravity crushes them inward in a final act of collapse. The outer layers rebound in a supernova, a single explosion so bright it can outshine an entire galaxy. For a brief moment, the night is lit by the death of a sun. And from that cataclysm come the heaviest elements in existence. Gold, silver, uranium, the iron in your blood. All of it forged in stellar death. Supernovae are not simply endings, they are beginnings. Their shockwaves travel outward, stirring the interstellar medium, compressing clouds of gas, and triggering the next generation of star formation. The galaxy feeds upon its own endings. Destruction becomes fertility. The remnants of these explosions take many forms. Some collapse into neutron stars, objects so dense that a teaspoon of their matter would weigh billions of tons. Others, if massive enough, become black holes joining the invisible chorus that hums quietly across the galaxy. These remnants do not disappear from the Milky Way story. They shape it. Their gravity sculpts stellar clusters, their magnetism drives cosmic rays, and their collisions forge the rarest elements in the universe. One of the most mysterious of these deaths is the kilonova, a brief blinding event that occurs when two neutron stars spiral together and merge. In those few seconds, gold and platinum are created in unimaginable quantities. Somewhere in the ruins of such an ancient explosion, the atoms of your jewelry, your electronics, and perhaps even your bones were once scattered as light. And so the galaxy breathes. Stars form. They live. They die. And from their deaths, new clouds of gas emerge, enriched, complex, ready to begin the cycle again. Astronomers call this process galactic recycling. The Milky Way is not static. It is an engine of renewal. The galactic fountain carries this process further. When clusters of massive stars go supernova, their combined energy can blow gas up out of the galactic disk into the halo. There it cools slowly, forming great arches of glowing hydrogen. Over millions of years, this gas rains back down into the disk, feeding new star formation below. The galaxy breathes through these fountains, a slow, majestic respiration across cosmic time. Even the interstellar dust participates. Tiny grains of carbon, silicon, and ice drift between the stars coated with simple organic molecules, alcohols, hydrocarbons, sugars. They carry the seeds of chemistry from one generation to the next. When these grains settle into forming solar systems, they bring with them the ingredients of life. In this way, the Milky Way spreads potential like pollen drifting endlessly through its spiral arms. Every breath the galaxy takes fills it with light, then releases it again. Over billions of years, this rhythm has slowed. The Milky Way's star formation rate is not what it once was. In its youth, it blazed with energy, creating new suns in furious abundance. Now it glows more softly, a mature spiral in its middle age. It still creates, but it does so gently, carefully, like a craftsman rather than a storm. Our sun is part of this quieter era. It was born 5 billion years ago in a peaceful corner of the galaxy, not amid chaos, but from a calm, cooling cloud. Around it, the planets formed. On one of those planets, the remnants of countless dead stars took new shape as oceans, air, and life. You are the galaxy's recycled breath, the atoms of long-dead suns made conscious gazing back at the stars that created you. When you look at the night sky, you are not simply observing light. You are looking at the ongoing conversation between matter and time. Each star is a sentence in that dialogue, each supernova a punctuation mark of transformation. The Milky Way writes and rewrites itself endlessly, using gravity as its pen and starlight as its ink. Even now, as you rest, this cycle continues. Somewhere in the galactic plane, a massive star is collapsing its outer layers, about to bloom into fire. Elsewhere, a new cloud is condensing, preparing to light its first flame. Between them, dust drifts like breath, carrying traces of both death and birth in a single exhalation. The galaxy is not static, not silent, not finished. It is breathing long, deep, patient breaths that last millions of years. And within those breaths, everything you are, everything you know, rises and falls. When your own life ends, your atoms will return to this same rhythm. They will drift into the air, into the sea, into the soil. They will become part of new forms, perhaps a flower, perhaps a cloud, perhaps a future being, who will one day look up at the Milky Way and wonder what it means to exist. The galaxy will continue to breathe. You are part of its inhalation now, a brief spark of light drawn from its endless lungs. And when you fade, you will join its exhalation, your matter scattering softly into the night, becoming part of the Milky Way once more. Nothing is ever lost, it only changes form, and that is the secret rhythm of the stars. Our sun feels so steady, a fixed point in the sky rising and setting with timeless precision. But on the scale of the galaxy, it is anything but still. The sun and everything that belongs to it, Earth, the planets, the comets, the faint Oort, cloud that stretches into the dark, are all passengers on an immense journey. We orbit the Milky Way center at an astonishing speed, about 230 kilometers per second, or more than 800,000 kilometers every hour. And yet the galaxy is so vast that one complete orbit, one galactic year, takes roughly 225 to 250 million Earth years. Since the sun's birth, it has circled the galaxy only about 20 times. Each of those orbits has witnessed an era of Earth's history. When our solar system first formed, the galaxy was a little smaller, its spiral arms tighter, its light younger. By the time the first complex life rose from Earth's oceans, we were already moving through a new region of the Milky Way under unfamiliar constellations. When the dinosaurs ruled the land, the sun was on the opposite side of the galaxy, entirely crossing through different waves of dust and starlight. And now, as you read this, our solar system is midway through its 21st orbit, drifting quietly through a small lane of stars called the Orion Spur between two grand arms, Sagittarius and Perseus. To imagine this path is to imagine time itself as a circle vast beyond comprehension. Every rotation of the sun around the galaxy marks the unfolding of entire geological ages, mass extinctions, and rebirths of life. Civilizations rise and vanish in the blink of this orbit. Empires, species, even continents, all of them are short flashes along the Milky Way's turning wheel. And yet, though we move so quickly, we never feel it. The stars seem still because our scale of perception was too small. But the galaxy is in constant motion. Every star, every cluster, every cloud dancing to gravity's ancient rhythm. The sun's orbit is not a perfect circle. It is slightly elliptical, bobbing up and down through the galactic plane like a cork on a dark ocean. Every 30 million years or so, our solar system drifts above and below the dense midplane of the Milky Way's disk. Some scientists have speculated that this oscillation could influence conditions on Earth, perhaps even correlating with cycles of climate change or extinction, though the evidence remains uncertain. Still, it's a haunting thought that as we glide through the galaxy's structure, our planet's history may respond in subtle ways to that cosmic motion. The path we follow lies near something astronomers call the corotation radius, the distance from the galactic center, where the sun's speed roughly matches the rotation speed of the spiral arms themselves. That coincidence gives us a kind of protection. We don't cross through the most dangerous, crowded regions of the galaxy too often. Supernovae are rarer here. Radiation storms are fewer. In this quiet corridor, life has had the luxury of time, 4 billion years of stability in which to evolve, dream, and wonder. You might think of it as the galaxy's habitable zone, a wide temperate band where conditions are just right. Closer to the center, radiation, black holes, and gravitational chaos make life difficult. Farther out, the thinness of matter makes planet formation rare. We live in the balance between. Not too bright, not too dark. A small system adrift in the Milky Way's calm middle sea. But even calm seas have currents. Our sun is not fixed to one spiral arm forever. Over the ages, it drifts inward and outward through the disk, following gravitational resonances like eddies in a stream. Sometimes we move closer to the crowded inner arms, where star formation blazes. Other times we drift outward toward quieter space. Every few 100 million years, our sky subtly changes. The stars we see around us today are not the same ones that shone on the first mammals, nor those that glimmered above the last dinosaurs. Constellations themselves are temporary, momentary arrangements in a long choreography. The familiar patterns we name and follow are like notes in a melody that shifts every few million years. Even our nearest neighbors, the bright stars of the Big Dipper Orion, or Scorpius are only passing by. They belong to other orbits, other ages. Tens of thousands of years from now, those constellations will melt into new shapes. The night sky we know is not permanent. It is a snapshot in the sun's long voyage. Our entire solar system is wrapped in a faint bubble of magnetic influence called the heliosphere. As we travel through the galaxy, this bubble shields us from much of the interstellar radiation that fills space. But the environment around us changes as we move. Denser regions of gas magnetic turbulence and cosmic rays drift past us. Each affects our little world in subtle ways. Changes in radiation levels, auroras, even the shape of Earth's upper atmosphere. In that sense, we are not isolated travelers. We are like a ship moving through invisible weather, the interstellar medium itself. Clouds of hydrogen, traces of dust, faint magnetic fields all form the background through which we drift. Every few million years, we enter new currents of this unseen sea. And one day far in the future, our solar system's journey will end. The sun will expand into a red giant swallowing the inner planets, its outer layers drifting away into space. What remains will be a white dwarf circling the Milky Way like a tiny ember. Earth will be gone, but the atoms that made us, the carbon, the oxygen, the iron, will scatter outward, joining the galaxy's grand cycle of renewal. By then, the Milky Way itself may have changed beyond recognition. Its arms reshaped its stars, rearranged, perhaps already merging with Andromeda into a new form. Our orbit will still exist, the ghost of a path through a galaxy that no longer looks like home. And yet the idea endures that in every age of the universe, there will be beings somewhere who look up and wonder what lies beyond their stars. They too will be passengers in motion, carried quietly through space by forces they cannot feel. So when you gaze at the night sky tonight, remember you are moving. Every heartbeat, every breath carries you through space at impossible speed around the sun, through the Milky Way, across the darkness between galaxies. You are a traveler on the galaxy's road, following a path laid down before there was life, before there was Earth, before there was light. The sun's long orbit is not a journey with a destination. It is a circle, endless, ancient, serene. A motion so vast you can only sense it in the stillness of night, in the slow turn of stars above the horizon, in the faint hum of the galaxy itself. We are wanderers, every one of us bound not by borders but by gravity, pilgrims in the spiral arm of a quiet galaxy, riding the Milky Way's rhythm through eternity. Every night, whether you notice it or not, another galaxy watches you. It hangs above the horizon as a faint smudge in the constellation of Andromeda, a blur of light so dim you might mistake it for a cloud. But that blur is a spiral galaxy, vast and graceful, much like our own. It is also moving toward us, and one day the Milky Way and Andromeda will meet. The two galaxies are the largest members of our local group, bound by the quiet, patient pull of gravity. For billions of years, they have been drifting toward each other across the void, their motion so slow that only precise instruments could reveal it. But the approach is steady, unstoppable. In roughly 4.5 billion years, they will collide. It sounds violent, a cosmic crash, a destruction of stars. But the reality will be far more elegant. Stars are so far apart that when the two galaxies overlap, almost none will actually collide. Instead, their gravity will reach out like hands pulling, stretching, folding. The delicate spirals of both galaxies will distort into long, luminous streams. Great tidal tails will arc across space, rivers of stars, connecting one galaxy to the other. For a while, the night skies of whatever worlds still exist will change beyond imagining. From those planets, the heavens will no longer be dark. The entire sky will be filled with light, a glowing swirl of billions of stars, new and old, tangled together in a slow-motion dance. The Andromeda-Milky Way collision will not be an instant event, but a process lasting billions of years. The first encounter will pull both galaxies into elongated shapes. Then they will swing apart, trailing immense bridges of stars behind them. Gravity will pull them together again for a second embrace. Slowly, their motions will merge their separate identities, dissolving into a single larger structure. Astronomers already have a name for what will remain Milkomeda, the merged galaxy, born of two. It will not be a spiral anymore. After the collision settles, the result will likely be an enormous elliptical galaxy, smooth, bright, more rounded than its spiral parents. Its core will glow fiercely with newly formed stars. Its edges will fade into a diffuse halo of ancient light. And at its center, two supermassive black holes, the hearts of the Milky Way and Andromeda, will spiral toward one another, merging into a single, even larger heart. That merger will release gravitational waves, ripples in the fabric of space-time itself, spreading outward across the universe. They will pass silently through the cosmic background, a final echo of the galaxy's union, the sound of two hearts becoming one. It is strange to imagine that the Earth might still exist when this happens. By then, our sun will be nearing the end of its life, swelling into a red giant. Our oceans will have long since boiled away, our skies stripped of air. The planet will be silent. But high above that lifeless world, the greatest sky in history will unfold. Not darkness punctured by stars, but light woven into every corner of space. Imagine standing on that distant world, the horizon awash with starlight, the airless sky glowing with rivers of fire. You would see Andromeda's arms stretched across the heavens, the two galaxies interlaced like silk scarves in slow collision. It would be the most beautiful end imaginable, not destruction, but transformation. Even now, traces of this future are visible. Between our galaxies, thin streams of hydrogen gas already flow, pulled by mutual gravity. The faint warp of the Milky Way's outer disk may be a ripple caused by Andromeda's distant tug. The meeting has already begun, its first whispers reaching us long before the main event. In the vast timeline of the cosmos, collisions like this are normal. Galaxies are social creatures. They grow by merging, by swallowing, by embracing. The Milky Way itself was once a swarm of smaller galaxies united by gravity into one. And so, in meeting Andromeda, it will continue the pattern of its own, becoming a new chapter in the endless cycle of gathering and renewal. When the two galaxies merge, their combined clouds of gas will ignite a burst of star formation. Tens of billions of new suns will flare to life, their light briefly doubling the brilliance of the night. But this frenzy will not last forever. Over time, the gas will thin, the new stars will age, and the galaxy will settle into calm, vast, dim, but stable. Beyond that, a greater silence awaits. As the universe continues to expand, distant galaxies will drift away faster than light can reach. In the far future, when Milkomeda is old and all others have vanished beyond the horizon, it may be the last island of stars visible in the cosmic dark. The night sky will grow empty. The galaxies that once filled it will be gone, stretched beyond the edge of perception. Only the merged light of our descendants, the Milky Way and Andromeda together, will remain. But that is still billions of years away. For now, Andromeda is a soft blur 2 million light-years distant, faint but clear through any small telescope. When you see it, you are looking at our future, at the place our stars will one day join. That faint glow in the night is not just another galaxy. It is destiny written in light. The pull between us and Andromeda is as real as gravity itself, because it is gravity, the patient hand that draws the universe together, one slow embrace at a time. Perhaps that is the quiet lesson of this coming merger, that endings are only another form of unity. Galaxies do not die when they collide. They become something new, more luminous, more complex, more beautiful than either was alone. And so will we. The Milky Way. We see the bright disk stretched across the night is only its innermost skin. Beyond that band of light lies something vaster, quieter, and older, the galactic halo. It is almost invisible, yet it may contain most of the galaxy's mass. Imagine it as an enormous sphere, faint and diffuse, enveloping the entire spiral like a transparent shell of light and gravity. It stretches hundreds of thousands of light years in every direction, so wide that if the visible Milky Way were the size of a coin, the halo would be a sphere the size of a small room. We live deep inside it, but we can barely see it. The halo is made of three things: ancient stars, globular clusters, and dark matter. Together, they form a kind of memory, a record of everything the galaxy has been. The stars in the halo are not like those in the disk. They are old, some older than the Milky Way itself, born in smaller galaxies that were swallowed long ago. They move on long, tilted orbits looping far above and below the galactic plane. Their light is faint, their numbers sparse, but they are our oldest witnesses. Each one is a relic of the galaxy's childhood, when the universe was still dim and new. Then there are the globular clusters, dense, spherical gatherings of hundreds of thousands of stars packed tightly together like glowing beehives. They orbit the galaxy in the halo, moving slowly, majestically, some taking hundreds of millions of years to complete a single loop. Many of these clusters are nearly as old as time itself, 12 or 13 billion years, and their stars still burn steady and golden long after most others have died. Astronomers once thought these clusters were just ornaments, decorative satellites circling the galaxy. Now we know they are time capsules. The stars inside them contain almost no heavy elements, showing that they were born before the universe had time to forge much metal. They are living fossils, preserving the conditions of the cosmos shortly after the Big Bang. If you could see the halo in its full glory, it would appear as a faint sphere of glitter, a snow globe of ancient light. But to our eyes, it is nearly invisible. Its stars are too few, too far apart, and its light too dim to compete with the bright disk. Only with precise telescopes and patient mapping can astronomers trace its outline, the faint arcs of stellar streams, the scattered globular clusters, the slow dance of ancient suns across vast distances. And even those visible remnants are only a fraction of the whole. Most of the halo's mass is made not of stars, but of dark matter, that invisible, elusive substance whose gravity binds the galaxy together. The dark halo extends far beyond the reach of light, shaping the Milky Way's rotation and defining its structure. Without it, the halo would not hold. The galaxy itself might fly apart. Within this ghostly shell lie clues to our galaxy's violent past. When smaller galaxies merged with the Milky Way, their stars were flung into long arcs that now form the halo streams. Astronomers can still trace them today, pale ribbons of starlight that wrap around the galaxy like scars. Some of those streams may be the remnants of entire galaxies that vanished billions of years ago, their names lost to time. The halo is not empty space. It's alive with faint motion stars drifting in slow orbits, gas rising and falling in galactic fountains, cosmic rays flowing through magnetic filaments. Even dark matter, though invisible, exerts its subtle choreography, shaping how everything else moves. There are other treasures hidden here too. Scattered throughout the halo are rogue planets, worlds that drift without stars. Some were ejected from their solar systems long ago. Others may have formed directly in the dark from collapsing clouds that never ignited. They wander alone, frozen and lightless, carried gently by the galaxy's gravity. There may be billions of them orbiting invisibly through this vast expanse, tiny echoes of the star systems that once were. And beyond those worlds, drifting still higher, lies a thin, hot gas, the coronal halo, a nearly transparent plasma heated by ancient supernovae. It extends farther than the stars, farther even than the dark matter halo we can model. This gas, though nearly invisible, may hold as much mass as all the stars combined. It is the galaxy's breath still expanding into the dark, glowing faintly in X-rays. If you could travel outward past the spiral arms, and through the outermost clouds of hydrogen, the starlight would thin until the sky behind you became black again. But even there, in the deep silence beyond the edge of visible stars, you would still be within the Milky Way's halo. Gravity would still hold you faint, but real, a whisper from the unseen center far behind. The halo reminds us that our galaxy is larger than we can imagine, that what we see is only the surface of something far more profound. It also reminds us that time itself has layers. The light of the halo's oldest stars began its journey before Earth existed, before even the sun was born. When it reaches us, it carries not just photons, but memories, messages from a younger universe encoded in age and motion. When astronomers measure these motions, they find that the halo is not perfectly balanced. It tilts, wobbles, and ripples as if the Milky Way were still settling from ancient collisions. Some parts rotate slightly, others drift against the grain. The galaxy's outer regions are not still. They are the echoes of history still reverberating through the present. In a sense, the halo is where the Milky Way keeps its memory, not in books or records, but in orbits and chemistry. The stars there are older than language, older than planets, older than the idea of time as we know it. And they are still moving, still circling, still whispering the story of how the galaxy became what it is. So when you look up at the Milky Way's bright river of light, remember that there is far more than you can see. Above it, below it, around it, an ocean of invisible matter and ancient stars drifting silently through the dark. It is the galaxy's ghostly halo, the faint eternal glow of everything that came before. And you are inside it always. When you step back far enough, the Milky Way, so vast, so infinite to our eyes, becomes a single point of light, a grain of dust suspended in a cosmic tapestry that stretches in every direction without end. To understand our galaxy's story fully, you must zoom out beyond its halo, beyond its neighbors, beyond the local group itself, and see where it truly lives. Our galaxy is not alone. It belongs to a family, a local group of more than 50 galaxies bound together by gravity. The Milky Way and Andromeda are the two giants, each surrounded by a swarm of smaller companions, the Magellanic Clouds, Leothera Draco Sculptor, and many others faint and fragile, like satellites circling a pair of celestial monarchs. Together, they drift through space, a loose cluster of light adrift in a larger current. That current is the local sheet, a thin, flat region of the universe where galaxies like leaves on a pond float along the gentle contours of gravity. The local sheet itself is part of an even greater structure, the Laniakea supercluster. Its name means immense heaven in Hawaiian, and it is an apt name for it contains over 100,000 galaxies. Imagine them all, each a whirlpool of stars, each with billions of suns, all linked by invisible filaments of dark matter. The Milky Way drifts on one of those filaments bound by gravity to Andromeda, and the smaller galaxies around it all flowing slowly toward a gravitational center called the Great Attractor, a mysterious region hundreds of millions of light years away. We cannot see it directly, for it lies behind the thick clouds of our own galaxy's plane, but we feel its pull. Even as the universe expands, stretching space like taffy gravity gathers matter into these great knots and threads, shaping the cosmic web. This cosmic web is the universe's largest structure, a vast network of filaments and voids, like frost on glass or neurons in a brain. Along the filaments, galaxies cluster. In the voids between, there is almost nothing at all. The Milky Way is one bright bead on one filament in this incomprehensible lattice. Light from the nearest galaxy clusters takes tens or hundreds of millions of years to reach us, light from the farthest billions. And yet, even across those impossible distances, there is coherence. The universe arranges itself not in chaos, but in pattern. The same laws that shape a star also shape a cluster of galaxies. Gravity repeats itself, echoing its geometry on every scale from atoms to suns, from galaxies to the grand web that binds them all. When astronomers map the positions of galaxies across the sky, the image resembles coral or lace, or the tangled roots of a forest glowing in the dark. It is both delicate and immense, a structure so large it defies comprehension, yet so finely detailed it feels organic. The Milky Way's spiral, so intricate and alive, is itself just a thread in this greater weave. Within this vastness, our galaxy moves. The entire local group flows toward a massive region called the Virgo cluster, home to thousands of galaxies. That cluster itself falls toward the Great Attractor, which lies near another enormous collection, the Norma cluster. Beyond even that lies the Shapley supercluster, one of the most massive concentrations of matter known. The scale is staggering. Everything moves, everything pulls, everything is connected by the faintest of forces stretched across the deepest of times. But what's most astonishing is that this cosmic web, vast as it is, represents only a small portion of the universe. Between its glowing threads lies darkness, dark energy, the mysterious force driving the universe's accelerated expansion. It acts not as gravity does, pulling things together, but as a quiet repulsion, pushing galaxies apart. The balance between gravity and dark energy defines the universe's fate. For now, gravity holds sway in our local corner. The Milky Way and its neighbors are bound together, their fates intertwined. But on the grander scale, dark energy wins. The filaments of the cosmic web are slowly stretching. Galaxies that are distant today will one day move beyond our cosmic horizon, too far for their light ever to reach us again. The web will thin its strands, drifting apart. The universe will grow quieter. Still, this vast architecture, this web of matter and time, tells us something profound, that the universe is not random. It is connected, layered, purposeful in its physics, if not in intent. The same invisible threads that hold stars in galaxies hold galaxies in clusters, and clusters in superclusters. The Milky Way's place in this design is humble but not insignificant. Without its precise orbit, its quiet neighborhood, its rhythm of gravity, we could not be here to observe it at all. Sometimes, when scientists look at deep field images from space telescopes, those long exposures that reveal thousands of faint galaxies packed into a single frame, they say it feels like staring into eternity. Each of those galaxies has its own stories, its own stars, its own children of dust and light. And somewhere within that endless web, one tiny spiral glows a little brighter to us because it is home. The Milky Way is one note in an infinite symphony. Its voice is small but steady, resonating through the cosmic web in harmony with all others. We are the echoes of that music, made of its dust, carried by its gravity, shaped by its rhythm. When you gaze at the Milky Way, you're not just seeing your galaxy. You're seeing the thread of a universal design, the shimmer of a filament that stretches across all time and space, connecting you to everything that has ever been and ever will be. You are part of that web. You always were. All stories, even cosmic ones, have endings, though in the universe, an ending can last longer than all of human history multiplied 1 billion times. The Milky Way, radiant and alive tonight, will not shine forever. Its beauty is temporary, though its silence will be eternal. Let us look forward far, far beyond the measure of our clocks. 100 million years from now, the galaxy will still look much as it does today. The spiral arms will turn gently. Stars will be born and die. The sun will have aged a little, its light slightly brighter, its planets a little warmer. But on the scale of the cosmos, that is the blink of an eye. In 5 billion years, our sun will swell into a red giant, its outer layers expanding until they engulf Mercury and Venus, perhaps even Earth. The inner solar system will melt into vapor. For a brief moment, the dying sun will cast off its outer gases in a glowing shell, a planetary nebula, delicate and luminous. At the center will remain a small white dwarf cooling slowly in the darkness. By then, the Milky Way and Andromeda will already have begun their merger. The two galaxies will have collided, their shapes torn and reformed into a vast elliptical body. Milkomeda, the new galaxy. Its heart will burn bright with the birth of new stars kindled by the collision of gas clouds. But as eons pass, that blaze will fade. The gas will be used up and the fires of creation will go out. In tens of billions of years, the last newborn stars will ignite small, dim red dwarfs that burn for trillions of years. The galaxy will no longer sparkle with blue light. Instead, it will glow faintly red like embers cooling in the night. Supernovae will grow rare. Planetary nebulae will dissolve into the void. Slowly, one by one, the bright stars will age into white dwarfs, which will cool into black dwarfs, cold invisible cinders drifting through the dark. The Milky Way's spirals will dissolve, leaving behind only a diffuse cloud of ancient remnants orbiting the merged heart that was once two galaxies. In 100 trillion years, the galaxy will enter what physicists call the degenerate era, a time when no new stars are born. The night will be empty. The only lights will be the slow collisions of old stars, the flickers of dying black holes, and the faint sparks of matter still falling inward under gravity's pull. The great black hole at the center, the merged remnant of Sagittarius A and Andromeda's core, will dominate what remains. Around it, the galaxy's survivors, white dwarfs, neutron stars, and planets without suns will drift slowly in silent orbits. Occasionally, one will stray too close. It will be torn apart, its debris flaring briefly as it falls into the abyss, a final candle in the long darkness. Eventually, even these black holes will not last. They will evaporate through a process called Hawking radiation, releasing their energy into the void. The universe will grow colder, thinner, and quieter still. In the farthest conceivable future, 100 years or more, the Milky Way will be gone. Every atom once part of it will have decayed or dispersed into a thin mist of radiation. And yet, even in this ending, there is poetry. Because the story of the Milky Way is not one of tragedy, but of transformation. The energy released by its stars will still echo through the universe as faint background light photons endlessly red-shifted by expansion. Those photons, those last whispers of ancient suns, will continue to stretch across infinity, carrying the memory of everything that ever was. The atoms that made you me and every living thing on Earth will not vanish. They will drift. Perhaps they will fall into a new pocket of collapsing gas where gravity kindles new fires once more. In a universe that knows only change, even endings may be beginnings beyond our imagination. Before that distant fate arrives, though, there will still be beauty. Long before the final darkness, long after the sun's light fades, the descendants of the stars we see tonight will continue to shine red dwarfs glowing for trillions of years. Their planets may host seas of frozen light, or civilizations adapted to dim warmth, or perhaps simply silence. Time will stretch and slow, and still some form of matter will persist, bound by gravity, telling the story anew in a different language of physics. To imagine such vast times is almost impossible for a mind built to count years in lifetimes. Yet it is comforting, too, to know that the Milky Way song will not end abruptly but fade gently like a lullaby whispered until even the singer forgets the words. If there are observers in that far future, if something somewhere remembers, they will not see a spiral galaxy. They will see a faint glowing sphere in a universe grown silent. And perhaps, if they listen closely enough, they might still feel the echo of what once was a band of light across a night sky, a million suns strong, seen from a small blue world that once looked up and called it home. The Milky Way will end as it began, not with fire, but with light dissolving into darkness. And in that darkness, perhaps, will lie the seeds of something new. For even the universe in its quietest moments still dreams. Every night when we lift our eyes toward the Milky Way, we are doing something both impossibly ancient and profoundly human. Before telescopes, before science, before written words, there were eyes, millions of them watching that pale river of light flow across the dark. Hunters, sailors, shepherds, monks, and lovers all gazed upward, seeing in those same stars stories that helped them make sense of the unknown. For the ancient Greeks, it was the spilled milk of Hera, the goddess's anger turned into a band of light, the Galaxias Kyklos, the Milky Circle. For the Maya, it was a celestial river, the path the spirits took to reach the afterlife. In China, it was called the Silver River, a bridge of stars separating the lovers, Niu Long and Ji Nu, who meet only once a year when magpies form a crossing. For the Aboriginal Australians, the Milky Way was not made of stars at all, but of dark dust clouds forming the shapes of ancestral beings dancing in the sky. We have always looked up and woven ourselves into the stars. Long before we knew what the Milky Way truly was, we knew that it mattered. It told us where we were and reminded us of how small, how connected, and how miraculous existence could feel. When Galileo first turned his telescope skyward in 1609, he shattered that dream and deepened it all at once. What looked like mist to the naked eye resolved into countless points of light. The Milky Way was not a cloud. It was a multitude billions of suns so far away that their light blended into one continuous glow. For the first time, humanity understood that the heavens were not a ceiling painted for us, but a universe of impossible depth. Centuries later, Edwin Hubble would reveal that the Milky Way itself was not the entire universe, but one galaxy among billions. Each glowing island of light in the night sky was another spiral, another world of suns. The cosmos became vaster, lonelier, and yet somehow more intimate. For in that realization, we found kinship, not isolation. If there are other galaxies, other stars, perhaps there are other homes too, other minds wondering the same things. Science, for all its rigor, has never removed the poetry from the Milky Way. It has only changed the language. Where ancient people saw rivers of spirit, astronomers now see stellar streams. Where they imagined gods and dragons, we now see nebulae and dark matter halos. Yet the emotional truth remains unchanged. We look upward because something in us recognizes home. In every age, the Milky Way has guided us. It told sailors where north lay. It helped farmers mark the seasons. It inspired myths, paintings, symphonies, and even revolutions in thought. To trace its light is to trace the evolution of curiosity itself, the part of humanity that refuses to be satisfied with darkness. And even now, when cities have dimmed the stars, the Milky Way endures. Pilots see it from their cockpits above the clouds. Campers glimpse it from mountaintops. Astronomers map it in wavelengths invisible to human eyes. Photographers chase it across deserts and ice fields, waiting for the perfect night when the galaxy's spine arcs across the horizon like a luminous bridge between heaven and earth. When we study it scientifically, we discover things about ourselves. The Milky Way is not just a place we live, it is a process we belong to. Every atom in our bodies was once forged in the heart of stars that lived and died billions of years before the sun was born. The calcium in our bones, the iron in our blood, the carbon in our cells, all of it was made by the Milky Way's endless cycle of creation and destruction. You are not simply in the galaxy, you are the galaxy. You are made of its history, its dust, its fire, its time. When you breathe, you recycle stardust. When you dream, your neurons flicker with energy, born from the same physics that ignites suns. When you die, the atoms that once made your thoughts will drift back into the world, and perhaps one day into new stars, new worlds, new forms of life. In this way, the Milky Way is not just a galaxy. It is a continuum of being, an endless conversation between matter and meaning. Its arms cradle everything that has ever existed here, our ancestors' fires, our satellites, our fears, our hopes. And what we give back to it in return is wonder. The universe may not care, but that does not diminish the miracle that we do. We are the eyes through which the Milky Way sees itself. We are its brief awareness of being alive. Tonight, as you lie beneath its soft arc, remember this: the same light that touches your eyes left its stars tens of thousands of years ago. When it began its journey, mammoths walked the earth. Glaciers ruled the north, and humans were painting animals on cave walls. That light has traveled through cosmic dust, through storms of radiation, through unthinkable distances, and yet it found its way to you. So when you look up, you are not just seeing the past, you are participating in it. You are finishing a journey that began long before you were born. Perhaps that is why the Milky Way feels so peaceful, so right to look upon before sleep. It reminds us that we are part of something vast yet intimate, ancient yet alive. It is both the map and the dream, the bridge between knowing and wondering, between science and silence. And so the galaxy continues to turn. Stars are born, stars die, and somewhere on a small blue planet someone whispers, "Wow." That whisper, your whisper, is part of the Milky Way, too. Hey everyone, if you're still with me, half awake, half dreaming, thank you. Tonight, as the last of the stars fade in your mind, I want to leave you with something quiet, something simple. Not science, not mythology, just stillness. Because sometimes the universe doesn't speak in facts or stories. Sometimes it just hums. Close your eyes. Imagine the Milky Way above you, not as a map or a spiral, but as a river of light. It flows slowly, gently across the dark, like breath. Every point in that river is a sun. And around some of those suns there are worlds, oceans, mountains, winds that have never been felt by any living thing. Now, zoom out. Watch from a distance where light itself looks slow. The galaxy turns with grace, a vast spiral glowing against the eternal night. Inside it, dust collapses into stars. Stars burst into flame, and from their ashes, new dust begins again. It is not a machine, not a perfect clock. It is a breathing thing. It inhales and exhales creation. In that rhythm, we exist. You exist. For a few heartbeats of galactic time, you are part of this pulse. Your life, with all its beauty and worry, happens entirely within one small moment of the Milky Way's breath. We think of stars as still, but they're moving fast, elegant, unstoppable. The sun carries you through the galaxy at over 220 kilometers every second. Even as you lie here, you are traveling through the Milky Way, orbiting the galactic core like a mote of dust on a warm breeze. You are moving through time, through space, through history. If you could see with cosmic eyes, you'd notice that the galaxy isn't silent at all. It hums with radio waves, whispers with neutrinos, flashes with gamma light. It glows in every spectrum we can imagine, and in some we can't. Its spiral arms are like chords in a symphony, rising and falling in waves of density and color. And somewhere in that cosmic music, your heartbeat fits perfectly. You are right now synchronized with the stars. There is a quiet kind of love in that idea, the thought that you and the galaxy share motion, light, and time. That even the smallest thought you've ever had, every sigh, every memory, every dream is made from atoms that once belonged to suns. The universe is not indifferent, it's participatory. You are what it uses to feel itself. If the galaxy had a lullaby, it would sound like the background hum of distant starlight. Not loud, not fast, just soft, endless, patient. It would remind you that nothing is lost, only transformed. That darkness is not emptiness, it's a place between moments of light. Picture a single grain of cosmic dust drifting through a nebula. It seems insignificant, but that dust carries carbon, oxygen, iron, ingredients of life. Millions of years from now, it might fall into a forming planet. Billions of years later, it might help form the blood of some creature that looks up and wonders about the stars. In that sense, every dust grain is a traveler, a storyteller. Now imagine all the travelers together, every photon, every atom, every soul that has ever existed floating in the spiral arms of this luminous sea. They spin, merge, dissolve, reform. They never truly stop, not even in death. Somewhere a star is being born, somewhere else another fades, and here on Earth you rest under their combined light, warm, temporary, eternal, all at once. The galaxy doesn't ask you to understand it, it only asks that you witness it, to feel for a moment the peace of being part of something too vast to name. If you listen closely, really listen, you might hear the faint echo of gravity weaving everything together, that slow, deep sound that has no words, the sound that moves worlds and hearts alike. And as you drift to sleep, remember, you are orbiting in a sea of stars. You are made of the same light you see. You are part of a story that began before language and will continue long after memory. The Milky Way will turn, the stars will breathe, the universe will dream through you. So breathe in once more, let go, and float. Good night, traveler. You're home among the stars.